Okay, so there's another couple of examples of games from last year's class. So you see that we've seen 3 of them, and there's quite a variety of different things you can do and different ways you can be creative. I particularly like that running game. It's one of my favorites. It was one of the most original ones from last year. And you see different people focus on different things. So last class we looked at a game that was really beautiful graphically. and very simple. It's just avoid being killed, and then you know this goalpost, I called it hand runner. I don't think it was given a name. Not great artwork, but still a really interesting idea. Okay, so what I would like to do now, things are a little bit different this year than last year. At this time last year, we were preparing for the final exam, but or not the final exam, the midterm exam, because that would have been next week. But this year the break is a little bit later, and so the exam is going to get pushed off. So I'd like to get us started working with PyGame. What's PyGame, you ask? Well, PyGame is a Python library for making games in Python. Exactly the kinds of games that I've just shown you. Those were all made using PyGame. A couple of things. PyGame is designed specifically for making 2D games. It's basically an abstraction of something called the SDL, which is basically a direct rendering library. It doesn't support 3D stuff. Now, of course, you can always implement your own 3D stuff on top of a 2D interface, a 2D library like this, but that's probably more work than anybody wants to do in this course. And I certainly won't be covering for example, the linear algebra that you would need to do that. So I don't recommend it unless you're super, super keen. And even then, if you are that keen, it's not the best way to do that kind of thing. So it's not really the right tool for the job. Now, these games, I don't know if you could hear it or not, but they all have soundtracks. They all have sound effects. There's all animation going on. There's things moving. They all take pictures and move them around on the screen. And so there's somehow a lot of stuff involved in making one of these games. So for this class and the next, we'll be looking at the features of PyGame, the various features for playing sounds and so on, and seeing how to use them. And we're not going to make anything particularly interesting. We're just going to see how to use each of these things. You know, in the same way that if you take a course in woodworking, you might first learn about all of the different tools that are available in your wood shop by doing simple things like cutting a piece of wood with a saw, or turning a simple cylinder on a lathe. Not making anything particularly interesting, just learning how they work. So that's what we're going to start with today. All right. So here, it takes a little bit of setting up to get something going in PyGame. Luckily, you can just, well, like most programs, the way most programs start is you start with a template and just reuse it. In this case, here's an example PyGame template. I want all of yours to start out using this template and having you add things as necessary. Let's just take a look at what this game does. There it is. Pretty exciting. Yep. It's a white window, and that's all it does. Okay. All which arguments? 44100, these are for the mixer, for the sound mixer. This is 44 kilohertz. I think this is maybe signed 16 bits. And then these may be block sizes, and I forget what the 2 is, but we can look all that up. Yeah.
It says the status of Windows 600 was 600, but 300 was 600.
Yeah, that's a typo. Okay, so let's see what happens here. So this is all encapsulated in a class called PyGame. Now, the main reason to do that, it's not strictly necessary to use a class or any object for this, but the main reason is that, well, games generally have a lot of state associated with them. So there's a lot of things that, you know, elements to a game, not this one in particular, but as we start adding things through it, we'll want to be able to maintain some state. And all that state is related to the game, so it makes sense to collect all those variables into some object, and indeed this is the object that we're going to use. So we're going to use this object to maintain everything we want to about the game, and it will also handle, well, that's it. This is what we'll use. Okay, so first thing we do is we set up the mixer. This is just some code that you have to include if you want to have any sound effects at all in your game. Then we have to initialize PyGame itself, the module. And if you look up at the top of this, we have imported, this is bad style, we shouldn't import two things on one line. We have imported PyGame. Now we create a screen, which was something called a screen, which is really a window. And that's by using pygame.display.setMode. We tell it the width and the height. And then we set up something called a timer. Here it is, this timer. And we tell it to send us a refresh message every this many milliseconds. Okay, so 1,000 divided, so there's 1,000 milliseconds in a second, and so we take 1,000, we divide by self.fps, and we'll get one of these events, they're called. We'll get one of those every that many milliseconds, so that's something like 33 milliseconds, which means that we'll get one of those events about 30 times per second. And then we do something that happens with all of these graphical types of user interfaces. We call something called the event loop. Now, this kind of programming takes a little bit of getting used to. So things like video games, things like programs that have a graphical user interface, they're usually what's called event-driven, because most of the time they're not doing anything. All they're doing is sitting and waiting for the user to do something or some event to happen so that they do something. This is true even of games. Most of the time they're just waiting for the user to click a button, or they're waiting for to click the mouse, to move the mouse, to do whatever, press a key, something, or they're waiting in between updates to the screen. You know, they're supposed to update themselves maybe 33 times per second. Well, 33 times in a second is not a lot for a computer, so there's a big gap of time between updates, and mostly they just sit there doing nothing. And when you have a program that does that, then it makes sense to not just sit there doing what's called polling, repeatedly asking, okay, is the user pressing a key now? Is the user, is it time to update the screen yet? Is the user moving the mouse now? It's better to just sit back, relax, give control back to something like the operating system, and just say, okay, tell me when something happens, tell me when there's something that I need to do, and then I'll do it. And that's what happens in this event loop. So if we look at this event loop, basically says this goes on forever, and we say, PyGame, once you have an event, give it to me. It'll give me this thing called an event. And events have different properties. One of the main properties is the event type. And right now, there's two kinds of events that we handle. One of them is defined by PyGame. It's the quit event. And the way we handle that is we exit. So the program shuts down. And the other type of event that we handle is the refresh event. And that's an event that we defined ourselves up here, and we've told PyGame to send us that event every 33 milliseconds. So every 33 milliseconds, we'll get a refresh event, but we might also get an exit event. And we handle those in different ways. If we get it's the quit event, we exit. And if we get the refresh event, then we draw ourselves. Okay, so what is it that generates this quit event? Well, that actually comes from clicking on the close window button up here. So nothing else generates that quit event. Let me... So Chrome, for some reason, is going crazy. That's better. Okay, so we handle these two types of events. One of them exits and the other one draws. And if we look at what the draw does, well, we see why this is kind of a boring application. It creates a color. A color is just a triple of 3 integers that tell you how much red is in the color, how much green is in the color, and how much blue is in the color. And white just happens to be all red, all green, all blue, as much as possible. It gives you white. And then we fill the screen with this white color. Now, there's one special thing that I need you to understand, and that's this idea of something called a double buffer. So the way we'll do things is we'll use this notion of what's called a double buffer, which you can think of as something like a piece of paper like this. And when you're trying to do animations in video games and things, what you have to do is there's some stuff you want to draw. And so, maybe there's some characters, the user's character that you want to draw. And then maybe there's some bad guys, and then you draw those. Maybe there's also a background, so you drew that first. And what you don't want to see, or what you don't want the user to see, is first the background gets drawn, and then the character, and then some other characters, and then maybe some trees and other things. You don't want the user to see all of those things popping up at once. So it uses something called a double buffer, which is similar to a piece of paper. And the way to think of it is, imagine that I'm the guy, I'm trying to play a game show you a game, or animate a game on this piece of paper. So I'm standing here on this side of it, and I'm drawing the next frame of the game on the back of this paper. Right now, you can't see anything that I'm drawing. All you see is what's on the front of this paper, which is the previous frame of the game. Once I'm done drawing and everything is ready, then I flip the paper. And you see a perfect image of everything the way it's supposed to be in this frame, with everything in its place. And now I can start working again on the back of the paper, preparing the next frame. So I might just wipe off this back of the paper and start from fresh, or I could even just add things or change things that are already there. So there's really 2 images always that are happening. One of them is shown to the user. The other one is the one that's being drawn on. Okay. So that's why these draw functions, they always end with a pygame.display.flip. If you don't do it this way, then you can really end up with things where you get a lot of flicker and stuff, because really, most of these draw functions start by wiping the screen clean and then drawing the whole scene again, which if you didn't have a double buffer like this, well, the user would see the whole screen go white like that, and then things start appearing on it. It would be very, very fast, but what that turns into visually is a sort of flicker in the game, and we don't want that. We want this to be as smooth as possible. This flip operation is designed so that the whole thing happens in the time it takes to do one refresh of your screen. So that basically it's not there in one frame, and the next frame the whole picture is there. There's no partial frames. All right. So any questions so far? Yeah. Whichever version works with your computer and your installation of Python. Yep. It'll start next week. So we'll be using PyGame on the next assignment. Yep. Yes, that's just it's just somebody being clever. Yeah, but that's always true. Okay. All right. So let's try something simple. We'll add. So this again, and this is really true now. I've sort of, said this before, but what you always want when you're developing something like this is to have a game or an application that works. It just may not do all the things you need it to do. And that's really true when you're making video games like this. The best thing to do is start with this because it works. It's a blank screen, you can exit if you want, and then you start adding some features to it. Never get yourself into a state where you have something that's not working at all and you're still a long way from making it work. You really need to do this very incrementally, very slowly. Start with the basics, get them going, and then start adding features. If a feature breaks your game, then pause, make sure that that gets fixed. If you have to, go back to an older version that continues to work if you're unable to fix it, and get back to something that's working. It's really, really pointless to do a lot of development on something that's not working at all, because there's a good chance then that you'll never get it working and it'll be a total waste. Okay, so let's start with something simple, and let's do that by going to the PyGame website and looking for the different kinds of events that we might want to handle. So far we've seen two of them, quit and our own event that we defined, which was the refresh event. And here's a list of some events. Quit, active event, not sure what that is, key down, key up, mouse moves, mouse motion, mouse button up, mouse button down, joystick handlers if you happen to have a joystick. I don't recommend making a game that needs a joystick because the TAs marking it probably won't have a joystick, so it'll be kind of useless for them. If someone resizes your window, you can even get an event for that, and a couple of other ones. And then this user event, which is one that you're supposed to use if you're defining your own events, as we've done. You start defining them as user event plus 1, user event plus 2, user event plus 3, and so on. So all of these are integers. You don't care exactly what their values are, but if you need to define your own kinds of events, you want to make sure you don't use any of these ones. So start with user event plus 1, user event plus 2, and so on. So one that I would maybe like to look at is key down or key up. And these are exactly what you think. The key down is user has pushed the key down on your keyboard. And key up comes when the user lets go of that key. So you actually get very precise information that tells you, exactly when it goes down, exactly when it goes up. And let's see, these things then have properties. So this says that key down has some properties: Unicode, key, and mod. So let's take a look at key down. There we go. So one of those properties is key. Here's a list of the names of all the keys in PyGame. So basically all the letters, all the numbers are there, colons, semicolons, all of these things are there. So let's augment our game just a little bit by saying that, well, there's another way to quit the game, and that's by pressing the escape key. So we go back to our event loop, and we want something like this. If event.type is equal to PyGame dot, I think it was key down, and so if it's a key down event, it has this property called a key. So event.key, if that is equal to, where did we go? The escape key. So let's find that. Escape. K underscore escape. So let's just see if we're handling this right. Print user, press the escape key. Okay, so there it is, and now we'll press escape, and indeed, we see every time we press escape, we get a, well focused on the window, we get a, well focused on this window, our code executes. So we're handling that code when we want to, and what we would like to do is have it exit, so we can just do that by moving that condition up here. Something like that. So this now gives us two ways to quit the game, either by pressing the escape key or by closing the window using, whichever way the operating system lets you do that. Let's try that. Escape, and that exits the game. So there's our first feature. And that's always a good one. It's pretty important to be able to quit the game. That's something users like. Okay, next up, it's going to be hard to do anything if we can't draw an image. So let's figure out how to draw an image, and for that we're going to need an image. So let's try finding an image. Where do we get images from? Well, we can create our own artwork, but that takes time and a lot of effort. One of my favorite places to go is to Google's advanced image search, because it has a few features that are useful for us. So what would we like an image of? Give me something.
A Python.
A Python. Okay, and I don't want the thing to be huge, so let's say larger than, let's say we would like it to be medium. don't care about the aspect ratio. And there's a particularly useful thing you can do with image search, which is ask about the colors or the type of colors in the image. And well, we'll see what that's good for in a second. But another really useful thing is to filter by usage rights. I don't know if you can see it here, but there's different licenses typically associated with images that you find on the internet. And I don't want to use something created by somebody who doesn't want me to use it. So I'll only ask for images that are free to use or share. I would like you to do that for assignments, yes. So only use images which have the user does not mind you using them. Yeah? Can you make your own? Yes, you can make your own. But I'm not offering any support on image editing tools or any of that stuff. So here's a lot of pictures of pythons. Do any of these look like they would be good for use in a video game? Not really, eh? So let's go back. Type of image, face photo, clip art. We can try that. That's a bit better. So maybe this guy here. He's a nice looking one. I'm not sure what this one is, but all right, and one thing you'll notice here is, notice the funny background, the checkered background. Anybody know what that means? It means it's transparent. And these transparent images are super handy for us in making video games, because it means if we draw them, no matter what the color of the background, it'll turn out correctly in this image. So it's not going to be that we're drawing a snake, a python with a big white rectangle around it. It'll just be whatever the color of the background is. Do you have a question? Yep.
Does Python support all image types, or are there certain image types that?
Not all of them, and I don't know what this one is. I know it works well with PNGs, so that's usually what I would use. And this is a, where's the name of it? GIF should work too, I think. But let's say it. Let's save it. Download. Oh, come on.
Just save image as. Yeah. Go back to you.
Yeah. Oh, it's a PNG, so it's perfect for us. And I want to go to Morin 1405. Okay. Good. So we've got this this image in that directory that we want. It's a PNG. So to draw an image, there's a couple of things that you want to do. So the first thing you want to do is load it. Now, you could, for example, do this. So you say image equals, let me look it up, PyGame dot image dot load. You give it the file name. So that creates one of these images, loads it, and then you want to draw it. Which looks like this. So you get the image. you draw it on the screen, and our screen is called self.screen. And image rectangle. Okay, so let's see how this works. So we load after turning the screen white, we load the Python image, we get its rectangle, which is basically a rectangle that tells us the size of this image. So if you'd like, we can print that, but we won't do that right now. And then we do what's called blitting it to the screen. So that means sending it as fast as we can to the screen. And when we draw an image onto a screen like this, so an image onto a window, well, we sort of have to say where to draw it, and we're going to draw it at that rectangle. Okay, so let's take a look at that and see what that does. So there we go. That draws this thing. It's almost the image is almost the perfect size to fit there. Maybe a little bit too big for this kind of thing. There's not much else left to do in our game if we're going to do this. So I could do something like move. Scale. There we go. So let's try that with a smaller image, a converted image. Where did he go? What's that? No, I shouldn't have to. Python.png, let's see what, the conversion may have gone wrong. So there appears to be nothing in that file. Is that the way the arguments work in convert? Okay, so that was 0.25%, I guess. Now, okay, so now we have a smaller one of these guys. Okay. All right. So, all right, there's certainly going to be, we're going to want to be able to do more than that. One thing worth noting is the location of this guy. It's up there in the top left corner. And that's, well, let's take a look. We told this thing to get drawn at this rectangle, so maybe we should take a look at what this rectangle is. So this rectangle is 0, 0, 160, 143. Now, so this rectangle is specified as 4 coordinates. The first coordinate is the left side. The second coordinate is the top. This is the right side, and then this is the bottom. And a funny thing happens in computer graphics, which is very different from mathematics, which is that the coordinate system looks like this. Over here at 0, 0 is the top left corner of your window. As you increase the y coordinate, you move down. And as you increase the x coordinate, you move to the right. And so, so we're drawing this thing at this rectangle 0, 0. Down here is 143. Over here is 160. And so this image is getting drawn into this rectangle here. So if we want to move that, we can move the rectangle. And where is that? So if we wanted to move this thing, let's say, I don't know, down, or let's say we wanted to move it to the right. So how would we, what coordinate do we need to change? The x coordinate. So rectangles, you know, they're a thing in PyGame. You can look up the documentation. You can say PyGame rectangle. You find the class, and you see that there's all these things you can do to rectangles. One of them is to move it, and you specify the change in x coordinates and the change in y coordinates, and you get back another rectangle. And so we can say rectangle equals rectangle.move. We want to move it to the right, so we want to do what to the x coordinate? Increase it by, I don't know, let's say 100. And if we don't want to move it down at all, we'll just leave the y coordinate unchanged. And indeed, it moved over 100 pixels to the right. Okay? Now, what if we wanted to draw this thing perfectly centered in our window? Okay, so the size of the window we have, we've saved the width and we've saved the height. So how would we make this thing centered? Yep.
You could use the height and the width divided by 2, and then plus subtract half the rectangles.
Okay, so you'd say, okay, well, centered means I look at the width and divided by 2, that'll give me the center on the x coordinate, and I look at the height divided by 2, and that'll give me the center on the y coordinate. And so you might say, all right, so let's say, let's move this rectangle. Self.width divided by 2, self.height divided by 2. And you, as you have already figured out, that doesn't quite do it. Now it's drawn at the center, but it's the top left corner that's at the center. So we need to fix that. We actually want the center of the image drawn at the center of the screen. And so that says we want to take the rectangle's width divided by 2 and subtract that off, and the rectangle's height divided by 2 and subtract that off. There we go. So perfectly centered. All right. Now, one thing that I would not recommend doing is exactly this. And the reason is, here we are loading an image inside the draw routine. So let's think about this for a minute. So loading an image means going to a file that's on the disk. PNG images are compressed, so that means reading the file and then doing some stuff to uncompress it, and that gives you an image in memory. Now, if we do this in the draw routine, that means we're doing this 33 times per second. And really, every time we're drawing, we're loading this thing and uncompressing it and drawing it. So probably we should first open this image at the beginning once, and then just reuse it over and over. So let's take this code for loading the image and move it up here when we initialize our game. So we might say self.python image is that. And now we don't have to load this thing 33 times a second. We just load it once, and then we repeatedly draw it. This computer can handle doing it 33 times a second, but once we get enough images and enough other things happening, that could get too pricey. Okay, so already you see that even for somehow some really basic stuff, there's a little bit of mathy things we have to worry about, like just centering an image in the screen. We had to do some a little bit of careful calculating there, and we could clean that up a little bit. Okay, so any questions so far? There's the first thing in our toolkit is the ability to draw an image. Yep?
Does it just move that image, or does it draw a new one every time?
It is, well, every time we're refreshing, all this stuff is happening. We're setting the whole screen white, and then we're drawing an image at the center of the screen. So every single time we're doing this. All right. Good. What else might we like to do? Let's try doing a couple of things. Maybe changing the background color and handling a keystroke at the same time. So we know how to handle a keystroke. So we could say something like, if we get a keystroke event, so that would be and that event happens to be somebody pressing the C key, then we might like to do something like change the background color. So how would we do that? So we might want to change the white variable. Now the white variable here is a local variable that's defined only in this function. So up here we don't have a way to change it. So we'll turn that into a property of this thing. Self.background color. So what should we change it to? Random. Okay. So we want this to be a triple, and we want it to be random values between random integers. So that's random dot rand range to 56. Random dot rand range to 56. Random dot rand see if that works. So now, when the user presses the C key, we change the background color, and the background color is what gets used here. Okay, so it's no attribute named KC, which means that's not the color, that's not the code for the C key. And I need PyGame key codes. It's a lowercase c. And then when I press C, we forgot to import random. And this is why you have to test after even the smallest changes. Now we get random background colors, and we see maybe the image needs some cleaning up because his eyes are transparent, but which is a little disconcerting. You might want to flood fill those with white if you were worried about this. Okay. All right. Something else you sometimes like to do is something like a game over screen. And so for that, sometimes you like to draw text. Lots of reasons to draw text in a game, even in a graphics game. If you're going to display a score, for example, you need that. If you have a game over screen, if you have any number of things like that, then that's maybe something you want. So let's see how we get text. So PyGame font. So if we're going to draw text, we have to choose the font that we want. And so what we want is, let's say, the default font. That's the name of the default font. Okay. So here's what we'll do. We'll say font file is pygame.font.matchFont. This takes a list of possible fonts that you want. So give me the names of some fonts. No, not Comic Sans. Nobody wants that.
Oh, that's
Arial. Helvetica. I don't know. Sans. Times New Roman. Ubuntu. It'll try its best. Although, let's leave Ubuntu out. And then we'll say font is pygame.font file. And how many points? 80? 12? 12-point font is usually way too small in any game. And 12-point font is already, just these things are 16-point. So let's try 24. And we'll save that for use later. now we'll say, so now we want to write some text. What should we write? Yep. You have a question?
Yeah. If I use a font that may not be available on the TA's computer, is that fine?
We'll see that you can include with your game true type fonts that this thing can load. And so then there won't be an issue of it not being available. You can include it. If you use a system font, like I'm doing here, then there is a danger that the system font on their computer is wildly different. So if that could cause some issues with spacing or something. Often it's better to just download a true type font that you can use. Yep.
Is it really complicated to draw something slowly? Like, for example, cursive writing to write its way across the screen?
Super complicated. I mean, basically then, well, I mean, not super complicated, but I mean, how complicated is it to draw cursive writing? I mean, just think of that. How would you draw cursive writing going slowly across the screen? Now, however complicated that is, and now you want to do it over a series of frames per second. So one frame you draw this much of what's written, and then the next frame you add this, and then the next frame you add this. And so it takes some significant effort. There's no routine in PyGame that's like nicely draw this thing slowly. Remember, PyGame, every routine there is just supposed to be instantaneous and come back because it's all, these routines get used inside the draw function, which is supposed to be as quick as possible because it's supposed to happen 30 times a second. So there's none of these things with a delay in them. Okay, so let's render, I don't know, hello world. So now we've got this text. And now we'll start to see a pattern. From this text, we can ask for its rectangle, and then we can blit this text. So I want to blit the text and to that rectangle. So let's see if that works for us. Self-dot takes at least 3 arguments. Self.font.render. What is that third argument? Ah, the color. Okay. Okay, so now we render this font, hello, this text, hello world, using this font here. Okay, so a couple of things to notice is most of the things that you draw on screen work this way. So you create them somehow, like here, for instance, we loaded an image, and that image came in, and it has a certain size, and that size is given by this rectangle. Here we rendered some text in a specific font that we had, and that gives us a rectangle, which tells us the bounding box of the text, and that's what we use. So, if we wanted to move this, we could. So let's say we wanted to center this at the top of the screen. So we could adjust that rectangle to move this text, like so. And then we take this object that we've created, which is actually an image in memory, and blit it into this target rectangle. So the pattern is always the same. You create this thing, which is actually an image in memory. So once I've rendered the text, I actually have an image, and associated with that image is a rectangle, and now I can move that rectangle and tell it to get blitted at that location. And again, if we're always going to render the same text, hello world, well, we might as well render that text up here only once instead of 33 times per second. That'll save us a little bit of a few cycles. Okay, good. So now we know how to draw text as well. It's exactly the same as drawing images. Once you've created the text, the funny part is actually getting it to creating the text image itself, which you get by first creating a font and then rendering a text in that font. And let's find a true type font that we could try out. Let's try, I don't know, Zatko Blade. Nope. Worst site ever. And it's #1. Yeah, this is the problem with searching for free stuff. So I won't do it now. Next time I'll bring try the download link. It'll probably make me sign up for something. No, maybe not. Good. Oneway.ttf. So let's try, instead of using that other font, let's try Oneway, and I think I have to specify the full file name. Good. So there it is with a font that we downloaded. That's the Oneway font. And let's go a little bigger. There you go. So, you know, download, again, look for, you can take font files which are free for reuse and use them in your games this way. Many of the system ones, first of all, they vary from system to system, so they're sort of unreliable that way. And the other problem with them is they're sort of boring. Yeah?
How would you go about updating text like if that is for the one that wasn't updated or
Okay, so well, let's do it. Self.frame equals 1. Self.frame. Okay, and we saw how to render text, so we did this. Render. So I have this variable now called frame. It's just an integer that's going to keep counting. In fact, it's going to go up every time we draw a frame. And then I'm going to use this font that I loaded earlier, and I'm going to render that counter as a string. So that could be a score, that could be whatever. Right now it's just a counter. And now that I've got this thing, let's not do the move, otherwise we'll overwrite our other text. Forgot to define black again. So there you go. Just one little bug. I forgot to get the rectangle. Oops. There we go. There. Okay, so there's your, something like a score or something that's increasing. Text that changes every frame. You just render it at the time just before you draw it. Okay. All right, let's look at sound. Okay. So again, we turn to Google, and let's find video game sounds. Video game sound files. Pill bottle is a good one, maybe. Sounds good. We download it. It's an MP3. That's not my favorite. I would rather have a WAV file. They always work. Video game WAV files. Boring, boring, boring. Here.
Calculating.
Good. So we get a WAV file that we can play, and now the pattern is similar again. A WAV file is this thing that sits on disk. We'd like to get it into memory once and then play it over and over. And so we want to load it. So here we'll say self.sound we get by doing PyGame.mixer.sound. Specify the name of the file we want. So now we've got this sound, and when we want to play it, so when would we like to play this sound? Not every time we draw the frame. That's not going to work. We don't want to play it 33 times per second. We could play it in response to some event, some key being pressed, for example. So maybe when the user presses the X key, we will play this sound. And that is with a mixer. Self.sound.play. Okay, so now if I press X, I just get a click. That usually means that this sound file isn't understandable by PyGame. But it's not a WAV file that I can use with this. We'll have to find a better WAV file next time. Okay. Now let's try and do something, I don't know, a little bit less trivial maybe. Let's try and make our image, let's say, move a little bit. So let's say we want to make this image of this Python, have it move back and forth. So how would we do that? Yep.
You need to give it a speed.
A speed. So how do you do that?
So you say that the rectangle's location
Yeah.
is equal to its current location plus, and then a variable you can call speed.
Well, let's be careful because the rectangle's location is actually so the Python is this guy here, and this rectangle is just the bounding box of that image, which starts always at 0, 0, and whatever. So it's not this rectangle. There's some other position that we want to play with.
Like the x coordinate.
Yeah. So let's say self.pythonx is maybe 0. Self.pythony, set that to 100. And now every time we draw this thing, we would like it, let's say we'll draw it at those coordinates. So we'll move to, rather than centering it, we'll move to self.pythonx and self.pythony. Make sure that part works. Good. So there he is over there. And now we want it to move. So maybe at every frame, we would like it to move a little bit to the right. So we'll say self.pythonx plus equals, I don't know, 10 pixels. And there he goes. Gone. Okay, so that has him moving off the screen. How about if we want him to come back when he gets to the end? Yep.
Reset as like when it hits the maximum value of x, reset to the value of x.
Okay, so let's, instead of always moving at 10 pixels, let's move it delta x pixels. And we'll start out with delta x equals 10. So this will still do the same thing initially. And when do we want this thing to not be moving 10 pixels to the right? So once the Python reaches the right side of the screen, we would like it to stop moving so far over there. And when is that? Yeah.
When x is greater than, I think it's 600, then we set the x value.
Okay, so you say if self.python x is bigger than self.width, the width of the screen. Aha. So there's that. But once we reach the right-hand side, what should we do? Change delta x to negative 10. Or reverse the direction. Okay. So let's see what happens now. So off he goes. And oh, here he comes back. And whoops. Aha. That solved the problem for a little while. So what else do we have to do? The opposite. If self.python x is less than 0, then again, sure. Because we do the same thing in either case. We reverse the direction. Oops. And he comes back. And he bounces back. So as one of you pointed out, even before we did this, there's a little bit of asymmetry here. He bounces as soon as he hits this wall, but he actually completely leaves on this side. And that's because, remember, Python x is the location that we're drawing the top left corner of the picture. So if we really want him to bounce off the other side, we need to account for the width of this thing. And so then the condition is if self.pythonx plus rectangle.width is bigger than self.width. There we go. Okay, good. And let's take a look, a little bit of documentation. So PyGame has a whole module for transforming things. And transform means changing, changing in some way the way that they look. So it can do flips, it can do scales, rotations, all kinds of things. And it can do this on any of these objects that you would draw in Python. So you can flip text, you can scale text, you can do all of those things. In particular, well, we could do this to this Python image. So let's see if we can get that to work in the next 2 minutes. So here we go. We created our Python, and this is the left Python image. And the right Python image is pygame.transform.flip, the left Python image. And I want to flip this across the x-axis, but not the y-axis. Okay, and Now, I'm either going to use one of these two images, one which has the Python going left and one which has the Python going right. How do I decide which one to use? Which variable tells me what's the correct one to use? Yeah? Whether x is increasing or decreasing. So the delta x tells me. Okay? So let's say image equals, or if self.delta x is less than 0. So if it's less than 0, that means the Python is moving in which direction? Left. The x-coordinate is decreasing, the Python is moving left. So then we'd say image is self.python image left. And otherwise, image is self.python image right. And now we're just going to use image. See how that works for us. Left Python image, the other way around. Left Python image. Right Python image. And up here, left Python image. Self.left Python image. And that was line 93. There we go. Good. So, very quickly we get from nothing to this game that would have sound if I had downloaded a good file. Changing background colors, an image that is animated in the sense that it moves, and it even changes its direction. So what we'll keep doing in the next few classes is or the next class is exploring more features of PyGame, and then you'll be implementing those on your next assignment.
What would